Hey everyone. So today we're going to trace the journey of a really powerful idea. It's one that started out in the kind of nerdy world of software testing, but now it's basically the most important ingredient for building smarter, more effective AI. Let's dive in. So let me ask you something. In your job, in your life, how often do you hear people talk about best practices? That one single, perfect, works every time way to do something? It's an idea that's everywhere. But is it actually true? Well, it turns out the answer is a big no. This quote right here, this is the core idea for our entire explainer. What works like a charm in one situation could be an absolute train wreck in another. Why? Because context is king. Here's a great way to think about it. You've got a recipe follower, right? They can make a decent meal if they follow the instructions perfectly, but a master chef, they understand the ingredients, the kitchen, the heat, the whole context, and they can adapt and create something amazing. That's the mindset we're talking about today. So where did this whole idea come from, anyway? Well, it all got started in a field you probably wouldn't expect: software testing. It's a philosophy called context-driven testing, and the idea is pretty simple, really. Instead of using some rigid, one-size-fits-all checklist to test every piece of software, this approach says, hold on, every project is different. The way you test it has to be custom-built for the specific people, the market, the tools. You get the idea. Okay, so this whole philosophy is built on these 7 core principles. Now, don't worry, you don't need to memorize all of this. Just notice the theme that keeps popping up. It values things like unpredictability, real problem solving, and human skill way more than just following rigid rules. I mean, look at number 3. It says people are the most important part of the context. And number 7 says you can only do the right thing through judgment and skill. This was never about writing better checklists. It was about empowering smart people to adapt. Okay, so we started with a philosophy that's all about human judgment. But how in the world did that idea make the jump from people to machines? Let's see. Well, that exact same idea started popping up in technology, just with a different name: context-aware computing. This is where systems are literally built to sense their environment, things like your location, the time of day, what you're doing, and then change their behavior based on that info. Sound familiar? Yep. It's the same principle: adapt to the context. And let me tell you, this isn't some small niche academic idea. We're talking about big business. The market for this stuff, for context-aware computing, is projected to be worth more than $266 billion by 2032. This philosophy of adaptation has become a massive economic engine. So how does a machine get aware, anyway? Well, it's all about this constant stream of data. Think about your phone. It's using GPS and accelerometers to know exactly where you are and if you're driving or walking. Your smart home looks at your past choices to predict what you want. The system is just constantly gathering all these signals to figure out the context, and then it adapts on the fly. And that brings us right up to today. Because this idea, the one that started with human testers and grew into computing systems, has now become absolutely essential for the most powerful technology we have: artificial intelligence. Not too long ago, it felt like everyone was completely obsessed with prompt engineering, just finding that one magic combination of words to get the perfect answer from an AI. But as AI gets way more sophisticated, that's just not going to cut it anymore. The real game changer now is something called context engineering. And look at the keyword here: systems. This isn't about one clever prompt. It's about building an entire system that is constantly and dynamically feeding the AI the exact right information, the right data, and the right tools it needs to get a specific job done. This slide just lays it out perfectly. Prompt engineering is all about tactics. How do you phrase one question a little better? But context engineering is about architecture. It's about building the whole information pipeline that sets the AI up for success before you even ask the question. It's kind of like the difference between being a good talker and being a brilliant researcher who shows up to the conversation already knowing everything they need to know. Okay, so we've followed this idea all the way from a testing philosophy to how we build AI. But what's the payoff? I mean, what are the actual, tangible, data-driven results here? Let's look at what happens in the real world. Let's start with the insurance industry. One company, by giving its AI all the context it needed, policy details, claims history, all the regulations, they saw an incredible 80% drop in claim processing errors. 80%. Then you've got Microsoft. They found that when their AI coding tools were given the full context of a software project, the engineering teams got 26% more tasks done. That's a huge productivity boost. And in e-commerce, the results are just staggering. Retailers who switched to context-aware systems that understood a shopper's history, what's in stock, even the time of year, they saw a 10-fold improvement in how many people responded to personalized offers, 10 times better. So when you pull it all together, the story is crystal clear. We're seeing huge drops in user frustration and coding errors, and just insane amounts of time being saved. Providing the right context isn't just a little tweak, it is a total game changer for performance. So, the big takeaway is this. An idea that began as a human-first philosophy for software testers has slowly but surely evolved into the absolute backbone for turning AI from a cool toy into business-critical infrastructure. It really all comes down to context. Which really just leaves us with one last thing to think about. The technology itself is getting smarter at a mind-blowing pace. But the real question is, are we getting smarter? Are we getting better at how we prepare, inform, and ultimately teach our AI systems to actually succeed in the real world? Thanks for watching.